Alright, so today we continue on this chapter on how to deal with fractions. Specifically today we're learning to multiply fractions. We're going to try to do this in a methodical way. So it goes like this. We first break it up into two separate categories. The first one is when we multiply fractions that have ones on the numerators. If they both have a 1 on top and a 1 on top, we take that as a separate case and we learn how to deal with those. And then once we get good at these, we'll try to venture out and see if we could multiply fractions that have other numbers on top besides 1. So first, let's try to do the ones with 1. I'll do this one just from basic facts that we already know, and then we'll package it together into a theorem. It'll go something like this. So here, 1/3 times 1/2. Suppose that's given. So that's the given phrase here. I could always say this is 1/3 times 1/2 times a 1. That's by multiplicative identity. 1 really does nothing when you multiply by it, so it's okay to add there. And then we think about it this way. What does it mean to have, what is 1/3, what is the definition of 1/3 and the definition of 1/2? The definition of 1/3 of that guy right there, it was born to be the 3 killer. So this one we know kills 3, and this one we know is good at killing 2. So that's what these are. I could supply a 3 and a 2 to kill those, but it wouldn't really be fair to supply the 3 and a 2 there unless we counter it with some inverses. So here, instead of having the 1 here, I'm going to write 3 times 2, because those are the ones I'm going to need there, but I'm going to do 1/3 times 2, just so that this times that is still equal to 1. That is by multiplicative inverses. This piece right here, this piece is the same as that piece, right? We'll make this one red and that one red. Those two pieces are equivalent. 1 is the same thing as 3 times 2 times its killer. And I explained a little bit about why that might be helpful. That might be helpful because I know the 3 will kill that 3 and the 2 will kill that 2. And in the end, these things will get killed, and then I'll have the answer, which is 1/3 times 2, which is a fraction multiplied together into 1. That's the strategy. Okay, let's talk is cheap. Let's see how it goes. I know I could, for example, this is all times. There's no plus or minus, so it's just one term. I could reassociate using the Associative Law of Multiplication, since it's all times. 1/3 times 2. This is Associative Law of Multiplication. And then I could switch these ones, and I have 1/3 times 3 times 1/2 times 2 times 1/3 times 2. What happened here is these two got switched into that. So that right there is called commutativity law. The 3 went that way, the 1/2 went this way. That's called commutativity law of multiplication. I'll go with the icon for that. And now I'm going to rearrange the parentheses and say, you know what, I can associate these ones, and I can associate these ones, 1/2 times 2, and I have 1 times 3 times 2 left over. Moving the parentheses or reassociating is famous. It's called Associative Law of Multiplication. Now it's already looking really good now, because the 3 times the 1/3 I know is going to be 1. The 2 times the 1/2 I know is going to be 1. And I'm going to have some nice stuff here left over. Exactly the fraction the way it's supposed to be. 1/3 times 2. This is by multiplicative inverses. These two are multiplicative inverses. They give you 1. These two are multiplicative inverses. They give you 1. And of course, 1 times 1 does nothing when you multiply by it. Multiplicative identity. Yippee-ki-yay. That's it right there. Beautiful proof. Logical steps of why 1/3 times 1/2 is the same thing as 1/3 times 2 on the bottom. Perfect reasoning, step by step, using only things that we've already accepted or stated as axioms or proven as theorems. Step by step. It's beautiful. And so we package this whole thing together. We shall package it and call it the Multiply the Bottoms Theorem, which is guaranteed to help you figure out how to multiply fractions that have a 1 on top and some normal number on the bottom. You have to be real non-zero numbers on the bottom. They don't have to be, but they certainly work when they are. Of course, there's exceptions. You can't have a 1/0. Well, you could, but you got to pay extra for that. 1 over infinity Those things have to be dealt with in a separate class. But for our class, for these little numbers, multiply the bottoms theorem, beautiful. It tells you that 1 over a times 1 over b is equal to 1 over a times b. It says just multiply the bottoms and glue the tops together like a 1. Beautiful, isn't it? And then, what can we do that? Maybe we can quote it anytime you want to use it. So if I have this, suppose I wanted to multiply that 1/3 times 1 over 5. I could say, well, if that's given, I could just say this is 1 over 3 times 5 by multiply the bottoms theorem. That has all the steps built into it. And so I could go with 1 over 15. Of course, that's by the times table. And there you go. That's how we multiply fractions that have ones on top. Pretty easy, right? So next, we want to talk about a different type of fraction. What if you had something different, like not a 1 over 3 times a 1 over 5? Forget that. But what if you had a 5 over 3 times a 2 over 5? Other things on top besides 1. The multiply the bottoms theorem is all good when you have ones on top. But the question is, what if you don't? For that, we have the multiply cross theorem. Come back and we'll do that one. We'll prove it and we'll use it. It'll be flawless. Perfect reasoning. Starbucks, they sell coffee. Ford, they sell cars. Mathematicians, we sell perfection, beauty, and creativity in reasoning like you've never seen before. Come back and get some.